The spelling bee that fixes statistics. 20,000 contestants. Most are mediocre. A few are brilliant. But with 20,000 people, some will look brilliant by pure luck. How do you separate real talent from noise? One contestant. One word. If they spell it right, you're impressed. A 5% chance of getting lucky on a hard word? Acceptable. One test at alpha equals 0.05 works just fine. Now imagine 100,000 contestants. Or 100,000 COVID tests. The infection rate is 2%. 2,000 truly have it. 98,000 don't. Among the healthy, 5% test positive by chance. 4,900 false alarms among the infected. 90% get caught. 1,800 true positives. Total positives. 6,700. But 4,900 of those are wrong. 73% of your positive results are false. That 73% is the false discovery rate. FDR, not the false positive rate. That's still 5%. The FDR asks a different question. Among the people you flagged, how many are actually healthy? At population scale, the answer is devastating. Now translate this to genomics. You're testing 20,000 genes. Each gene is a contestant in a spelling bee. Some genuinely spelled hard words. Truly differential genes. Others just got lucky on easy ones. False positives. 1,000 contestants will have p less than 0.05 by pure chance. The Benjamini-Hochberg procedure is how the judges separate talent from luck. Step 1. Line up all 20,000 contestants by their raw p-value. Best to worst contestant number 1 had the smallest p-value. The most jaw-dropping performance. She spelled pneumono-ultramicroscopic silicovolcanoconiosis correctly. Contestant number 20,000 barely tried. Step 2. The judges start at the worst performer and walk toward the best at each contestant. They compute an adjusted score. The raw p-value times the total number of contestants divided by this person's rank. Contestant 10. Raw score 0.75. Adjusted. 0.75 times 20,000 divided by 10. Still terrible. Not significant. Next. They keep walking left. Computing adjusted scores. The penalty is for the sheer number of contestants. Being impressive among 20,000 is harder than among 5. Eventually the judge reaches a contestant whose adjusted score drops below the threshold. 0.05. Right at the line. From here leftward, everyone gets significant. The judge switches stamps. But here's the twist: sometimes the adjusted score spikes up. Contestant number 4. Raw p equals 0.00005. Adjusted. 0.25. But contestant number 5 already got 0.24. That's absurd. Number 4 is more impressive but gets a worse score. So the judges apply the minimum rule. Your score can never be worse than the person to your right. They cross out 0.25 and write 0.24. The more impressive contestant inherits the better score. This guarantees Q values never zigzag. The final result. A clean line of Q values that only go down as you move toward more impressive contestants. A vertical line drops at 0.05. Everyone to the left gets a trophy. Significant. Everyone to the right goes home. The guarantee. Among all the trophies you awarded, at most 5% went to contestants who just got lucky. To recap, one test at alpha 0.05. Fine. 20,000 tests. 1,000 false hits by pure chance. FDR. The fraction of your discoveries that are false. Benjamini-Hochberg. Rank all genes. Adjust backwards. Enforce the minimum rule. Draw the diagonal. Q value. The honest, adjusted p-value for each individual gene. Always use adjusted p-values when testing thousands of hypotheses. 20,000 contestants. 1 procedure. Honest trophies. If this helped, hit like and subscribe. See you in the next one.